Yesterday, AI bias showed us what happens when training data goes wrong. Today, we switch from problems to powers. Today, we give AI the ability to see. Think about everything your eyes do in a single second. Recognize faces, read signs, judge distances, spot motion. Today, we discover how computers are learning to do all of that. This is Computer Vision, Episode 9. So that's the big question, right? I mean, how does a machine, something built from pure code and logic, actually see? For you and me, seeing is just second nature. It's effortless. But for a computer, it's one of the biggest challenges out there. How do you possibly teach a pile of circuits what a cat is, or how to understand a stop sign? Well, the secret isn't about teaching it to see. It's about teaching it to understand numbers. See, before we can even think about giving AI this superpower of sight, we have to translate our world, a vibrant photo, into a language it can actually process. And the only language a computer really truly speaks is math. It's all about numbers. Okay, this is the first thing you've got to wrap your head around, and it's kind of wild. That beautiful picture on your phone, to a computer, it's not a picture at all. It's just a giant grid of numbers, like a massive Excel spreadsheet. Every tiny dot of color, what we call a pixel, is just a number, and we're talking millions of them. A single high-def photo can easily have over 2 million pixels. So let's break it down with something simple, like a black and white image. Look at this grid. Each pixel is just one single number. That's it. It's usually a value from 0, which means pure black, all the way up to 255, which is pure white. And all the numbers in between? Well, those are just all the different shades of gray. So the computer isn't seeing a picture, right? It's just seeing this grid, this map of brightness. But what about color, you ask? Well, it's pretty much the same idea, just with a little twist. Every single colored pixel on your screen is defined by just 3 numbers. One for how much red is in it, one for green, and one for blue. Yep, the classic RGB model. By just tweaking the levels of those 3 colors, a computer can create literally millions of different shades. So a colorful photo, it's just a massive grid, but this time every cell has a set of 3 numbers in it. Okay, so we've got the image translated into a huge wall of numbers. Awesome, but now what? How does the AI find a cat in that data? This, my friends, is where the real magic starts. It all comes down to a special kind of neural network we call a convolutional neural network, or a CNN for short. Okay, picture this. Imagine a tiny magnifying glass, or a little window that slides over the entire grid of numbers. It moves left to right, then down, then left to right again, scanning the whole thing. We call this a filter. And here's the key. It's not looking for a whole face or a car. Nope, it's hunting for the simplest, most basic patterns imaginable. And what kind of patterns are we talking about? We're talking about the absolute basics. The very first layers of the network are just learning to spot things like a vertical line, a horizontal line, maybe a diagonal one, or even just a simple change in color from light to dark. That's it. That's all it's doing at this stage, finding the simplest building blocks in the image. But here's where it gets really, really clever. It's all about layers. The first layer finds all those simple little edges. Then, the next layer looks at the work of the first layer and starts putting things together. It's like it's saying, a vertical line right next to a horizontal one. Hey, that's a corner. Or, I see a whole bunch of tiny curves here. That looks like some kind of texture, maybe fur. And you can see the whole journey right here. Now, if you've been with us since the beginning, this should look pretty familiar. Remember back in episode 4 when we talked about deep learning? It's that same peeling the onion idea all over again. The AI builds its understanding layer by layer. It goes from raw pixels to simple edges and curves to combining those into shapes and textures, then to identifying parts of an object, like an eye or a wheel, until finally, the top layer puts it all together and says, aha, that is a car. So, where can you see this whole system working at absolutely incredible speeds? In the real world? Well, look no further than the mind of a self-driving car. I mean, this stuff isn't science fiction anymore. It's real-world engineering happening on our roads as we speak. Just think about the insane amount of work this AI has to do. In the blink of an eye, literally, it has to spot and identify everything. We're talking lane markings, traffic lights, pedestrians, other cars, road signs, random obstacles on the road, you name it. And not just on a perfect sunny day. It has to do this in blinding sun glare, in heavy rain, in thick fog, in the middle of the night. It's making split-second life-or-death decisions based on what it sees. It's just an incredible feat.
But you know what? This technology goes way beyond just convenience and cool cars. It's now becoming one of the most powerful tools we have in medicine, and it literally has the potential to save millions of lives.
Let's bring this home to India. Right now, there are over 100 million people living with diabetes in our country. And a really serious complication is something called diabetic retinopathy. It's a condition that, if you don't catch it early, can cause blindness. And here's the problem. We just don't have enough specialist doctors to screen every single person who needs it. And this is where AI changes the game. Look at these numbers. After being trained on hundreds of thousands of eye scans, an AI can now spot diabetic retinopathy with 94% accuracy. That is exactly the same level of accuracy as a senior, highly trained human doctor. Just think what that means. We can take specialist-level diagnosis and put it in clinics in small towns, in rural villages, places that have never had that kind of access before. And please don't think for a second this is just some futuristic tech happening in labs overseas. Computer vision is already here, deeply woven into the fabric of modern India, solving problems for us today. I mean, it is literally all around us. You know when you drive through a toll plaza and your FASTag is scanned? That camera reading your license plate? That's computer vision. When satellites are analyzing farmland to check on crop health for our farmers? That's computer vision. How about quality control in factories, where it spots tiny defects no human eye could catch? Yep, computer vision. It's even being used on drones to inspect bridges and power lines. It's here, right now, making things work better and safer all across the country. So up to now, we've given AI this incredible power to see. It can watch the world, understand it, identify things, but it's all passive, it's just observing. Which leads to a really fascinating question. What happens when we hook that sight up to the ability to act? Computer vision gives AI passive awareness. It can see and understand. But what about AI that acts, that makes decisions, that learns by doing, not by watching? Tomorrow in episode 10, we explore reinforcement learning, where AI plays millions of games, fails millions of times, and eventually becomes superhuman. It is the most exciting kind of AI learning there is. See you in episode 10.